Hello and welcome back to Physics for the 21st Century. My name is Greg Perugini and we'll be doing this topic on dimension analysis. You might have heard it called chain analysis, or you might have heard it called unit analysis. But this is a tool that we use a lot in physics to not only verify our answers, but actually to come up with the solutions to many of the equations that we'll be using throughout this course. If you remember in the previous topic, we talked about Standards International, the units that we'll be using throughout this course. And these units, for length, we use meters, and mass, we use kilograms, and time, we use seconds. These are the units that we use as fundamental units to describe and to actually derive other units from, whether it be speed, or density, or velocity and acceleration. But let's get right on to the topic, dimension analysis. It is, as I said, a technique to check the correctness of an equation or assist in deriving an equation. We have these dimensions, whether it be mass, time, whatever, and we can use them as algebraic quantities, can cancel them algebraically on either side of an equation. Both sides of the equation must have the same dimensions, and any relationship can be correct only if the dimensions on both sides are equal. So it's best to really show this with a few very simple examples, but you can take it from there. Let me write out just one very simple. How many centimeters in a mile? Well, it seems like a simple question. You do need to know a few conversion factors, and there are a lot of conversion factors throughout your book. A lot of them are actually listed in summary at the beginning and ending of your books. Typically, that's how the authors of the book do this. But there are 2.54 centimeters in 1 inch. We know that. We also know that there are 5,280 feet in 1 mile. So those are the conversion factors that we need to do this particular example. So let's begin. And one of the first things you do in dimension analysis, I find this easier to do this, is write down what units we're looking for. We're looking for centimeters per mile. Okay? And actually, I can write this centimeters in little shorthand notation, centimeters like that. So how do we get centimeters per mile? Well, we know we need in the denominator miles. There is 1 mile, or I should say 5,280 feet in 1 mile. Well, I need to get feet out of the equation. We know for every foot we have 12 inches. And we know, based on what we have down here, that for every inch, okay, equals 2.54 centimeters. We need centimeters in the numerator. So just like that, you can look at this and say, I cancel the inches out. Anything we can do with numbers algebraically, we can do with units. I cancel the feet out. What am I left with? Centimeters per mile. On this side of the equation, it's the same units I have on that side. So that gives me my answer. 2.54 times 12 times 5280 over 1 times 1 times 1 will give me the answer here. Now I can write that in exponential notation. And you can see I used my little shorthand centimeters there. So that's a very brief, very quick example of dimension analysis. Let me do another one real quick. Why not? What is another good one? Let me see. How many meters in a furlong? A furlong? Well, what is that? Well, you can look it up, and if I give you one of these type of problems on an assessment, you would see I have to either give you that conversion, or for that matter, I have to give you time to find that conversion. But a furlong is 1/8 of a mile. We also know there are 1,609.3 meters for every mile. So given those two conversion factors, you may want to stop the video here and see if you can come up with the answer using dimension analysis. So let me then give you the solution. How would we go about this? Well, as I said, I like to write out meters per furlong. That's what the units I want the answer to be in. And so I definitely need furlongs in the denominator, and we know that there are 8 furlongs in 1 mile. Well, that gets the furlongs in the denominator. Definitely don't want miles in the numerator, but we know that 1 mile equals 1,609.3 meters. So like we did before, we can cancel out the miles, and we have furlongs in meters left over, which match on this side. So you just simply can do 1,609.3 times 1 over 8 times 1 to get the answer, meters per furlong. Should get something like 201.2 meters per furlong. So those are two real quick examples. You can find many examples online and in your book on this. Make sure you know this material fairly well when you go about doing the assessment. You'll be given problems with units and conversions necessary to find the requested solution. You should know the basics, though, you know, that there are 100 centimeters per meter, 1,000 meters to a kilometer, 1,000 grams to a kilogram. Your book will have some common units of measurement, and you may want to have that handy for your assessment. Just like before, you'll have a limited amount of time to do this particular assessment. You'll have 2 attempts, the last attempt counting. And make sure you give yourself enough time to do the assessment, as in you know when it's due. Because if it's not done by the due date, midnight on the due date, it will be a 0. And so it's fairly straightforward, fairly disciplined topic, but it's one that we use many times throughout all of physics and throughout all this course. So good luck.